Hello, and welcome to this lesson on solving multi-step inequalities. This is just a continuation of the previous two lessons where we learned one-step inequalities using addition, subtraction, and then multiplication and division. This is putting those all together in like two-step and three-step and multi-step, and we might even get inequalities with variables on both sides. I don't remember, but we'll see. Central question says, how do I solve multi-step inequalities? Did you know that inequalities can be used by many jobs you wouldn't think of? A truck driver is not someone that many people would think is needing inequalities. But here are some examples that they might need to know, like, well, the obvious one, like their speed would need to be less than or equal to the speed limit. You're allowed to go under the speed limit, but you're not allowed to go over the speed limit. You can get a ticket for that. The distance that they can travel, like their gas distance. So if they fill up their tank, how far can they go? Well, if they know a full tank can take them 640 miles, they know that the distance they have left is less than that. And if they used half of a tank, then they'd be going 320 miles, stuff like that. And we also have this other example here. So an 18-wheeler truck stops at a weigh station before passing over a bridge. The weight limit on the the weight limit on the bridge is 65,000 pounds. Most bridges have weight limits, unless it's like one of those super sturdy bridges, but most like a smaller bridge, they actually have a weight limit. The cab in the front of the truck weighs 20,000 pounds, and the trailer in the back weighs 12,000 pounds. When empty, in pounds, how much cargo can the truck carry and still be allowed to cross the bridge? That's kind of an important deal for the truck driver, because if they don't know the weight of their cargo, and they don't know if their truck is less than 65,000 pounds, if they try to cross it, they could damage the bridge and kill themselves and maybe others, so that would be bad. Okay, so even somebody who drives a truck might need to use inequalities. Circle type. Go ahead, quickly throw in your circle types and your inequalities that match with it, and I'll do the same quietly. So there's the setup, and then hopefully you have something like that. This is the third lesson now we've seen this, where the hollow dot gets the less than and greater than, the solid dot gets the or equal to's, the one with the extra little line underneath. Less than or equal to, greater than or equal to. All right, so there's really, honestly, not going to be anything new terribly in this lesson. It's just combining old skills together. This is really just a combination lesson. So, I mean, I'm going to solve the inequality. I'm going to get rid of addition and subtraction before multiply and divide. We learned about this way long time ago when we were talking about solving equations, and if that's unfamiliar to you, maybe you go check out the lesson on solving equations with variables on both sides. Or, I'm sorry, solving multi-step equations. 17 minus 8 should be 9, but my brain's not working. It's not even 7 in the morning yet. Oops. But that actually does confirm my answer. 17 minus 8 would be 9. All right, and I divide by 3, I divide by 3. W is greater than 3. I'm going to go fast because we don't need to go slow at this point. Hopefully, we're good and you know how to solve an inequality in an equation. So 3, 4, 5, 2, 1. I need a hollow dot because this is just a greater than. So I'll get the hollow dot, and because it's a greater than, I'm going to shade to the right. And there we have it. First problem, done already. Letter B, same deal. Line, I'm going to get rid of the add and subtract before multiply and divide. So I'm going to add 19 to both sides. 8m is now less than or equal to 24. When I divide by 8 on both sides, these cancel. M is less than or equal to 3. And graph. 3, 4, 5, 2, 1. I'm going to get a solid dot at 3 this time, because of the or equal to. That little line right there makes it a solid dot because 3 is an answer. And I'm going to shade everything that is less than 3. Less than is to the left. And that's it. So 2 problems down already. Okay, I did 2. You do 2. Go ahead and pause the video and do this right now. When you're ready to continue, hit play, and we'll go through it together. All right, letter C. You might have noticed that letter C might have been a little bit tricky. There were 2 places in this problem where you could have made mistakes, I could see. Common mistakes. All right, so solving. First thing you would do is you would subtract 31 on both sides. We're getting rid of the add and subtract. Remember that this negative sticks with the 2. This is a -2, not a -31. You don't read from right to left. This is a positive 31, so you get rid of it by using a minus. And so we'll have -2z, and let's see, 43, 31, that should be 12, positive 12. And then from here, we're going to divide by -2 on both sides. And of course, you remember that when you divide by a negative, you change the direction of that inequality, right? When you divide by a negative, you change the direction of the inequality in the middle of the problem. But because the variable is also on the wrong side, we're going to flip the whole problem around like that. So we had to change the direction of the inequality twice. Once because we divided by a negative, once because our variable was on the wrong side. And now we graph. -6. Nope, see, I almost made that mistake. I was putting a -8. That would be a -4, and that would be the -8. Remember, in negative land, these numbers are less negative. As you get smaller, the numbers are more negative. I get a hollow dot, and I'm shading greater than to the right. Now, letter D should have been much easier, because letter D was just like all the other ones we've done. So I'm going to -9 on both sides. 5D is greater than or equal to 44 minus 9 is 35. Yep. Divide by 5 on both sides. Those cancel. D is greater than or equal to 7. And then graph 7, 8, 9, 6, 5. Solid dot at +7 shaded to the right, which is greater than. There. Much quicker, much easier. All right, we're 4 problems down in less than 9 minutes. Let's keep going. And if I'm going too fast for you, pause the video, slow it down. Oh, look at that. We do get variables on both sides. I wasn't sure, but here we are. So let's see. Let's see how this is similar, different, at all, if anything. So if you remember the steps of solving an equation, the first step was to distribute to get rid of parentheses. There are none. Second step was to combine like terms on each side. Like if I could combine anything here, I would. If I could combine anything here, I would. There's not. Third step was to get rid of the variable on the right. Now that actually stems from a large part these problems, because we want to get rid of, we like having our variable on this left hand side. So if we get rid of this one on the right, if I would add 7r, that will make it so our variable is always on the air quotes correct side. So now we have 1r plus 3 is less than or equal to 9. And then we just kind of keep solving like normal. By the way, that 1 in front of the r, we don't really need it. This is still 1r. We just don't have to write the 1. That 1 is a ghost 1. So we solve by subtracting 3 on both sides. and r is greater than or equal to 6. Solid dot at 6, shaded to the right, greater than right. Let's see. No parentheses. I can't combine like terms, but I've got the same variable on both sides. So let's subtract the one on the right to get rid of it. Oh. That one's also going to cancel. I mean, 3 minus 3 is 0. 3 minus 3 is 0. I got -7 is less than -7. Okay. So we ask ourselves, is this true or false? Well, this is false. This is not true. -7 is not greater than -7. They're equal. It's the same thing. So it's not bigger than itself. This is not true, which means this problem has no solution. You're always looking for the truthiness of that statement. Because that statement is not true, we would say then it has no solution. Okay. Now, what would a graph of that look like? We can still graph that. We'd go like this. 0, 1, 2, -1. You still fill in a number line, but you don't shade anything. Remember, the answer to an inequality is everything that's being shaded in. So like 6 is an answer, so is all of these decimals in between, and 7, and 8, and 9, and everything else that way. Well, here, since there is no answer, we still have a number line. We just don't shade anything in. Okay, these two are for you. If you go ahead and pause the video, take your time, do them on your own. When you're ready to continue, hit play, and we will go through them together. All right, letter C. Let's see what we got here. No parentheses, no combining like terms, so I'm going to get rid of the variable on the right. That gives me -7 minus 5t is less than 8. Okay, I'm going to add 7 to both sides to get rid of that -7. -5t is less than 15. I'm going to divide by -5 on both sides, and we got t is now greater than -3. Did you make that change? When you divided by -5, did you change the direction of the inequality? Check yourself. You should have. Which means your graph would be -3 like this. You would have a hollow dot at -3, and you would be shading to the right. You'd be shading greater than -3. Letter D. Well, we're going to subtract 5d first. -7d minus 4 is less than or equal to 10. I'm going to add 4 to both sides. -7d is less than or equal to 14. Divide by -7 on both sides. D is now greater than or equal to -2. And again, we had to divide by a negative, so we changed the direction of that inequality. -2, 0, -4. We need a solid dot at -2. And we're going to shade greater than, which is to the right. These numbers are bigger than -2. So those were your two. Okay. Here are a few more that you could try. And after this, we should be getting to the application. So these are the last three we'll call them basic problems. So why don't you go ahead and pause the video and try these three right now. When you're ready to continue, hit play, and we'll go through them all together. All right, so I'm gonna make my marker a little smaller just because, well, these are a little bit more cramped. I've got 3 on this one page. Okay, so I'm gonna start by subtracting 3x on both sides. That gives me 2x minus 12 is less than or equal to -4. Continue solving, add 12 to both sides. 2x is less than or equal to 8. And then finally we divide by 2 on both sides, and x is less than or equal to 4. That would be 4, 5, 6, 3, 2, solid dot at 4. There, to make it solid. And we're shading less than, which is the left. So there's complete number 4. Number 5. I'm going to start by distributing. 5m plus 25 is less than 5m plus 17. Now my brain's working on overdrive, and I can see this one's not going to have a solution, because when I subtract 5m on both sides, those cancel, and we get 25 is less than 17, which is not true at all. So this problem has no solution. Your variables canceled out on both sides. The resulting inequality was not true. There is no solution. So you just fill in any number line. You don't actually have to fill in this number line. If you don't like putting negatives, do 1, 2, 3, 4, 5. There. And you just don't color anything in, because this problem does not have an answer, so nothing gets shaded. Number 6. I can see this also will have some sort of special solution, because when I distribute here, I'm going to get a -8s, and I see there's a -8s there. Those two will cancel each other out in a step or two. What happens after that, I don't know. Let's see, -4 times by -1 is a +4, and now I do know. So if these two -8s's cancel each other out, we're going to be left with that. Add 8s, cancel. Add 8s, cancel. 1 is less than or equal to 4. Is that true? Well, yes. So this is not no solution like we had before. This is all real numbers. Basically, everything. Every single number is an answer to this problem. Every single number will make this right side bigger than the left side, or the left side will be smaller than the right. So how do we graph that? Well, kind of like the other one, we can just throw in any random numbers we want. But the difference here is our shade. Since every single number is an answer to the problem, we need to shade in everything. So you just shade in the whole number line. All right. Applications. Says you want to buy some candy at the store. You get some gummy worms at $2 a pound and 2 boxes of Nerds at $1 each. How many gummy worms can you buy with Nerds if you only have $7 to spend? Okay, so you want to buy gummy worms and Nerds, but you only have $7 to spend. So you don't have to spend all $7. You can spend less than or equal to the $7. Okay, so this is my verbal model. This is getting an in-between step between the words and the equation. We're starting to get some math symbols in there. So gummy worms are $2 a pound. So I'm going to put I'm just going to put 2G because the cost would be $2 times by each pound of gummy worms. G is like the number of pounds. Number of pounds. N, it says, was the nerds, and you bought 2 boxes of nerds at $1 each. Okay, well that's just $2 in nerds. Boom! Now we've got ourselves an inequality. So this is the inequality that would match that. And now we would solve. Let's see. If you subtract 2, 2G is less than or equal to 5. Divide by 2, G is less than or equal to 2.5. Yes, we can get decimal answers. You can get half a pound of gummy worms. So my graph would be, I would put 2.5 here. And then I would go 3 and 3.5 and 2 and 1.5. I would count by 0.5s. So by half pounds. And then I needed a solid dot at 2.5. I wasn't sure which symbol I should use, so I had to relook. It is a solid dot at 2.5. And I'm shading less than to the left. There. So you could buy any amount of gummy worms less than 2.5 pounds. You could buy 1 pound of gummy worms. You could buy 2 pounds up to 2.5, including 2.5. But not more, because then that would cost more than the $7 you have. On an elevator, there are a bunch of kids and an adult. Each kid weighs 70 pounds and the adult weighs a solid 200 pounds. How many kids could be on the elevator before the 1,000 pound weight limit is reached and everybody plummets to their death? Kind of makes a difference, doesn't it? I mean, if that's the weight limit of the elevator and the cable can't support more than 1,000 pounds, then you probably shouldn't push it and put more than 1,000 pounds on there. So let's see. So you got a bunch of kids and an adult. And we probably want this to be less than 1,000 pounds. We don't want to go equal to. And it says how many kids could be on the elevator before the 1,000 pound weight limit is reached. Okay. So, well, we know the adult weighs 200. It said so right in the problem. And the kids are 70 pounds each. So 70 per kid plus a 200 adult. We want that to be less than 1,000 pounds. All right. And we solve. So we subtract 200 on both sides. Divide by 70 on both sides. 800 divided by 70 is 11.43 kids. Now, I don't think it makes sense to have 0.43 of a kid on your elevator. You can't just take an arm and a leg of a kid and put it on the elevator and save the rest of them for the next trip. So in this problem, you're talking about people, a decimal answer doesn't quite make sense. So I don't think we're going to use a decimal answer. How many kids could be on the elevator before the weight limit is reached? It would be, K would be less than 11 kids. 11 kids is okay. 11 is less than this. 12 kids would be too much and everybody dies. So 11 is what we're going to go with for our answer. 11, 12, 13, 10, 9. We can have... Actually, this would be an equal to 11, wouldn't it? Because you're allowed to have 11. I almost put a circle around 11, but you're allowed to have 11. You just can't have more than 11. So 11 would get a solid dot, which is kind of different. But I came up with this because I was thinking, like, well, 11 is less than this. 11 is an allowed number, so it wouldn't make sense to have a hollow dot as the original symbol was, because 11's allowed. There. So we had to change our answer quite a bit from the original answer, because the original answer doesn't quite fit the reality of a problem, I mean, having decimals of a kid and stuff. Okay, last of these, I believe. Yep, last problem. Legless can carry a 5-pound bow and a quiver of arrows. If each arrow weighs 0.3 pounds, what is the number of arrows Legless could carry and still be carrying less than 14 pounds? I mean, he's an elf, he's got to run through the forest, so he can't carry too many things. He got to be light. So why don't you go ahead, pause the video, write out your verbal model, write out your inequality, and solve this problem if you can, please, including your graph. All right. So I would say bow plus arrow, we want it to be less than 14 pounds. The bow weighs 5, and each arrow weighs 0.3, so that's 0.3 times by the number of arrows. Should be less than 14. I'm going to shrink this a little bit. We got to get a little bit more space to work. So then if we subtract 5 on both sides, these cancel. 0.3a is less than 14 minus 5 should be 9. Divide by 0.3 on both sides. And over here, a is less than, I bet you that's 27. 9 divided by 0.3 is, 30. Didn't expect that, but it was close to 27. 30. So he can carry less than 30 arrows. Now again, decimal arrows don't quite make sense, but we don't have a decimal here. So we're going to go 30, 31, 32, 29, 28. So we can go hollow dot at 30. 30 is not a number of arrows he can carry, and less than that. And then we would just have to understand that it would not make sense to have like point something arrows. You can't have half of an arrow or part of an arrow. So this would only be like whole number answers, 29 and 28 and 27. And I suppose we could have done something similar here. I don't know if you need to change your answer, but I'm thinking here, like, could we have just said, okay, we've got a hollow dot here at 11.42, and then our graph would look like that. I think that would be acceptable as well, because I mean, it's still less than this, and that would mean that shows that 11 is one of our possible answers and everything less than it as well. I think this would have been an acceptable graph as well. I don't know. Math is not always 100% straightforward. Sometimes you have some choices to make. Summary. So how are inequalities different from equations? Now that we've been through a few lessons on it, what are some of the differences between inequalities and equations? Go ahead and pause the video, think about it. Well, inequalities get a graph. That's a big difference. Inequalities, at the end, you have to graph the inequality, but we don't have to graph equations. So, 1. When you're graphing when you're solving your inequality, there are times you have to change the direction of the inequality, the direction of that symbol, like when you multiply or divide by a negative. And so far, that's it. Everything else has been pretty much the same as an equation. Okay? Thanks so much for watching this lesson. Until next time, toodles.